General high-rate emergency depressurizing of plant facilities is typically used to immediately and quickly evacuate equipment inventory in an emergency. High-rate emergency depressurizing can be initiated automatically and/or manually, depending on the type of plant or emergency and the safeguarding strategy. The implementations for high-rate emergency depressurizing systems are primarily distinguished by the use of normally energized or normally de-energized solenoid valves. The consequences of failure on demand and unintended depressurization, safe failure, define the acceptable implementation. Note: in addition to failure on demand assessment, the IPF classification methodology includes the probability of inadvertent opening and its consequences, e.g., environmental damage, production loss, damage to plant equipment, such as reactor internals or cladding, disturbance to reactor beds. Low-rate operational depressurizing of plant facilities is typically used for process control or other operational reasons. It is initiated automatically and/or manually. Low-rate operational depressurizing systems shall be equipped with air failure closed valves to minimize the risk of inadvertent depressurizing. In most applications, a low-rate operational depressurizing valve is required in parallel with a high-rate emergency depressurizing valve. Where simultaneous opening of both valves would cause the acceptable blowdown rate, typically limited by the rate of depressurizing and by flare capacity, to be exceeded, the low-rate operational depressurizing valve shall be automatically closed upon opening of the high-rate emergency depressurizing valve. Where multiple high-rate emergency depressurizing systems and/or multiple low-rate operational depressurizing systems are installed, simultaneous opening of these valves might cause the acceptable flare capacity to be exceeded. Such cases might require process sectioning and need to be addressed separately by a risk assessment, e.g., QRA, HAZOP, and/or Technical Desk HSE review. Measures to prevent flare capacity being exceeded are not covered by this document. High-rate emergency depressurizing guidance on the selection of system implementation. IPF classification will ultimately define the acceptable arrangements. High-rate emergency depressurizing system. System requirements. The minimum system requirements for an air failure open high-rate emergency depressurizing system are: 1. Instrument air supply to the depressurizing valve shall be assured by the use of an SIA buffer vessel. 2. Starting at the maximum upstream process pressure, the minimum downstream process pressure, and with the actuator loaded at the upper design pressure of the SIA system, the depressurizing valve shall be fully open within 20 s from initiation. 3. Initiation and reset shall be possible from a safe and remote location, usually the control room. 4. Electrical power shall be supplied from the vital power supply system. 5. Design requirements as detailed in the relevant guidelines. A typical arrangement of a high-rate emergency depressurizing system includes an air failure open valve and one normally energized solenoid valve. Note: a normally energized solenoid valve means in this context that the solenoid is energized under normal operating conditions, i.e. with the depressurizing valve closed. Another typical arrangement includes a high-rate emergency depressurizing system with an air failure open valve and two normally de-energized solenoid valves in series. Note: normally de-energized solenoid valves mean in this context that the solenoids are de-energized under normal operating conditions, i.e. with the depressurizing valve closed. Valve requirements. The minimum requirements for a high-rate air failure open emergency depressurizing valve are: 1. The body nominal size should not be less than DN50. 2. The valve should have a metal seat and shall be tight shut-off in the forward flow direction in accordance with IEC 60534-4 leakage class V. 3. The actual capacity CV factor of the valve should not be less than the calculated value, nor should it exceed this value by more than 10%. This may result in a non-standard trim size or a special construction. In this case, the actual valve CV shall be demonstrated by a test in accordance with the control valve capacity test procedure of IEC 60534-23. 4. The Mach number in the valve body outlet shall not exceed 0.7. 5. The noise generated by the depressurizing valve shall comply with the criteria for the absolute noise limit, sound power level, defined in relevant noise control guidelines. If a low noise valve design is applied, It shall be verified to ensure that fouling will not cause the valve to plug. To prevent plugging, no filter shall be installed upstream and no low noise restriction plate or silencer downstream of the depressurizing valve. 6. The valve actuator shall be of the single-acting spring-to-open type, preferably with multiple springs for redundancy. Double-acting piston actuators shall not be used. 7. High-rate emergency depressurizing devices require periodic testing, and hence the depressurizing valve with its accessories should be located to allow easy access. 8. The valve actuator shall be sized for traveling from the fully closed to the fully open position and vice versa at the maximum upstream process pressure, the minimum downstream process pressure, and the minimum SIA pressure. The manufacturer shall submit the actuator sizing calculation to the principal for approval. Low-rate operational depressurizing. Low-rate operational depressurizing system. System requirements. In certain applications, such as in smaller exploration and production facilities, low-rate operational depressurizing is initiated by manually opening the valves. The minimum system requirements are: 1. Starting at the maximum upstream process pressure and the minimum downstream process pressure, the depressurizing valve shall stroke from fully closed to fully open and vice versa within 30 s from initiation when operated from the manual station and within 20 s from initiation when operated via the solenoid valve. 2. The manual control station shall be located at a safe and remote location, usually the control room. 3. Design requirements as detailed in the relevant guidelines. A typical arrangement of a low-rate operational depressurizing system includes an air failure close valve with positioner and one normally energized solenoid valve. Note, a normally energized solenoid valve means in this context that the solenoid is energized under normal operating conditions, i.e. the valve position is controlled from the manual control station via the valve positioner. Valve requirements. The minimum requirements for a low-rate operational depressurizing valve are: 1. The valve body nominal size should not be less than DN50. 2. The valve should have a metal seat and shall be tight shut-off in the forward flow direction as per IEC 6U534-4 leakage class V. 3. The actual capacity, CV factor, of the valve should not be less than the calculated value, nor exceed this value by more than 10%. This may result in a non-standard trim size or a special construction. In this case, the actual valve CV shall be demonstrated by a test in accordance with the control valve capacity test procedure of IEC 6U534-3. 4. The Mach number in the valve body outlet shall not exceed 0.7. For applications where the valve will be used more than 10 times per year, the Mach number shall not exceed 0.3. 5. The noise generated by the depressurizing valve shall comply with relevant noise control guidelines. If a low-noise valve design is applied, it shall be verified to ensure that fouling will not cause the valve to plug. To prevent plugging, no filter shall be installed upstream and no low-noise restriction plate or silencer downstream of the depressurizing valve. 6. The valve actuator shall be of the single-acting spring-to-close type. Double-acting piston actuators shall not be used. 7. The solenoid valve shall be installed between the positioner and the valve actuator, so that when high-rate emergency depressurizing is initiated, the low-rate operational depressurizing valve closes irrespective of the output of the manual control station. Low-rate operational depressurizing system with additional automatic initiation system requirements. This low-rate operational depressurizing system is in the operational safeguarding of plant units, such as platformers, hydrotreaters, and hydrocrackers, where automatic initiation from the process is required. The minimum system requirements are: 1. Instrument air supply to the depressurizing valve shall be assured by the use of an SIA buffer vessel. 2. Starting at the maximum upstream process pressure and the minimum downstream process pressure, the depressurizing valve shall stroke from fully closed to fully open and vice versa within 30 s from initiation when operated from the manual station. 3. Starting at the maximum upstream process pressure, the minimum downstream process pressure, and with the actuator fully unloaded, the depressurizing valve shall be fully open within 20 s from initiation via any of the solenoid valves. 4. The manual control station shall be located at a safe and remote location, usually the control room. 5. Design requirements as detailed in the relevant guidelines. A typical arrangement of a low-rate operational depressurizing system includes an air failure close valve with positioner, one normally energized solenoid valve, and one normally de-energized solenoid valve. Note, one normally energized and one de-energized solenoid valve means in this context that the normally energized valve is energized and the normally de-energized valve is de-energized under normal operating conditions, i.e., the valve position is controlled from the manual control station via the valve positioner. Valve requirements. The minimum requirements for the low-rate operational depressurizing valve for this arrangement are: 1. The normally de-energized solenoid valve shall be installed between the normally energized solenoid and the valve actuator, and the normally energized solenoid shall be installed between the positioner and the normally de-energized solenoid to create the following command hierarchy. High-rate emergency depressurizing closes the valve. Other instrumented protective functions open the valve. Manual control allows operator manipulation. 2. The valve actuator shall be sized for traveling from the fully open to the fully closed position and vice versa at the maximum upstream process pressure, the minimum downstream process pressure, and the minimum SIA pressure. 3. To prevent instrument air consumption, no instrument air pressure regulator shall be installed downstream of the non-return valves. Specific design requirements. Valves special attention shall be paid to depressurizing valves in which the differential pressure across the valve results in a temperature drop that causes freezing of the stuffing box and ice formation on the stem. Valves shall be provided with an extended bonnet for this condition. Low-rate operational depressurizing valves, unless designed to be locally operated manually, shall be supplied without handwheel and without mounting facilities for a handwheel, such as brackets or threaded holes. For remote valve status display, a high-rate emergency depressurizing valve shall be provided with a limit switch for the fully closed position. Fireproofing. In normally de-energized high-rate emergency depressurizing systems, the valve, the secure instrument air supply buffer vessel, and all associated accessories shall be of fire-resistant construction. The fire resistance duration shall, as a minimum, enable the system to perform its function within the time required for depressurizing. Above-ground signal cable in the field shall be of fireproof construction, i.e., able to withstand temperatures of at least 750 degrees Celsius for a period of 90 minutes. Note: if the depressurizing system is located outside the fire risk area, the above fire-resistant requirements may be relaxed subject to the approval of the principal. In normally energized systems, fireproofing and/or protection is optional due to the fail-safe nature of the system. For all systems, the above-ground instrument air supply lines downstream of the isolation valve on the main instrument air header and pneumatic signal lines shall be made up of stainless steel tubing and compression fittings. Line monitoring. For normally de-energized high-rate emergency depressurizing systems, the IPS input circuits from the depressurizing initiating device and the IPS output circuits to the solenoid valves shall be permanently monitored for open circuits, short circuits, and earth faults. These faults shall generate alarms but shall not result in the opening of the high-rate emergency depressurizing valve. The method of circuit monitoring and alarming requires the approval of the principal. Signal segregation. Redundant IPS inputs from the depressurizing initiating device shall not share the same power supply units, input cards, racks, and field and/or system cabling. For a high-rate emergency depressurizing system employing two solenoid valves, the signal wiring and cabling in the control auxiliary room and in the field shall run via separate routes. Each output shall be initiated via separate power supply units, output cards, racks, and field and/or system cabling. The principal shall approve the philosophy of separation. All redundant inputs/outputs of depressurizing systems shall be segregated from the non-redundant inputs/outputs of other DCS IPS. The principal shall approve the philosophy of segregation. SIA buffer vessel. Upon instrument air supply failure, the SIA system shall maintain sufficient pressure in the buffer vessel to allow for at least 3 valve strokes. Unless otherwise specified, the size of the buffer vessel shall be based on a minimum instrument air header pressure of 4.2 bar, GIA. Notes: 1. One stroke of a valve is a movement from the fully open position to the fully closed position, or vice versa, i.e. 3 strokes starting from the closed position means closed open, open closed, and closed. 2. Air buffer vessels may require a safety relief device if located in a so-called fire area. The air charges required for 3 valve strokes of a single-acting emergency depressurizing valve are as follows: fail open, 1 charge; fail closed, 2 charges. For each application, the sizing calculations for the capacity of the SIA buffer vessel shall be submitted to the principal for approval. Each depressurizing valve that needs an SIA system shall be provided with a dedicated SIA buffer vessel and a dedicated IA header branch. Testing IPF calculations define the required test intervals and the test procedure to meet the PFD of the SIL. Depending on the required test intervals, facilities may be required to test the solenoid valves by initiating them individually, i.e. one by one for implementations with 2 solenoid valves. Furthermore, a locked, open, manually operated valve downstream of the emergency depressurizing valve may be required to allow testing, i.e. opening of the depressurizing valve while the process pressure is present. A locked, open upstream valve with a downstream vent valve should be provided if the replacement of the depressurizing valve is required during normal operation. The test plan and test facilities require the approval of the principal.